This is the screencast for section 4.8, example 6, calculating harmonic motion. In example 5, we use the cosine curve to calculate the harmonic motion of a piston's repeated back and forth action. Now we are going to use a sine curve to model a spring condensing and expanding from its resting position. A mass oscillating up and down on the bottom of a spring, assuming perfect elasticity and no friction or air resistance. So in other words, the spring is going to keep going forever, which we know in the real world it would not, but we're going to assume that for the purpose of this problem. This can be modeled as harmonic motion. If the weight is displaced a maximum of 5 centimeters, find the modeling equation if it takes 2 seconds to complete one cycle. So we're just looking for the equation in this problem. It's not asking us, like example 5, for a difference of anything. We're just looking for the model. Well, the A value, the amplitude of the spring, is 5 centimeters. The spring is going to stretch from 0 to negative 5 centimeters and 5 centimeters. So the amplitude, or A, is 5. Now the other question is you got to find the W value. Well, they told us that the equation, that it takes 2 seconds to complete one cycle. 2 seconds for one cycle. That is the period. 2 seconds to complete one cycle. So 2 units on the x-axis, which would be time. 2 seconds for one cycle to repeat, which means the frequency is 1/2, the reciprocal of the period. So that is 1/2 of a cycle per second. 1/2 of a cycle is pi radians, 1/2 of a circle, pi radians. So that's pi radians per second, which would be our W value. Y equals 5 times the sine of pi t. That will be the equation that will model the harmonic motion of a spring. Now try problem number 29. Same situation. A mass on a spring oscillates back and forth and completes one cycle in 0.5 seconds. So one cycle in 1/2 of a second. Well, that's a little bit weird. That is the period. So the period is 1/2, which means the frequency is 2. So backwards from the other problem that we did. Well, if the frequency is 2, that means this spring will complete 2 cycles in 1 second. 2 cycles is 4 pi radians. 4 pi radians in 1 second. So our W value is 4 pi. Final equation, Y equals, our amplitude is 3 centimeters. We're stretching 3 centimeters from resting position either way. So 3 times the sine of 4 pi